Hi, boys and girls. Mrs. Jockel here to teach another math lesson for you. Today, I have a little special guest. This is Beardy. He is my son's bearded dragon, and he's here to help teach about area. If you remember, last week we were talking about perimeter, which is the distance around a shape. And this week we're going to talk about area. So area is the inside part of a shape. And so when trying to build Beardy's lizard tank, I had to calculate the area of his tank, so the space within the bottom, in order to get tile to lie down for the bottom of his tank. So I needed to measure the length and the width of his rectangular tank, and then I was able to calculate how much tile I would need to fill in the bottom of his tank. And I chose kind of like a brown color, as you see, to kind of match in with like the dirt and sand that he would be used to. I also went exploring around my house and was finding some other examples of when I would need to know the area. And I recently had my husband do a little project in our extra bathroom with some pallet wood. So you can see the picture over on the right is showing my half bath, and I had him calculate the area of the wall behind our toilet. And so he, again, had to measure the length and the width, and he was able to calculate how much wall space there was, and he could then determine how much pallet wood he would need to nail up behind the toilet there. And so you could see he did a nice job measuring out the area of that wall, because he was able to cover the wall completely with pallet wood. Another recent project I had my husband work on was redoing our main bathroom floor. We had a crack over near the bathtub, so we had to replace the floor. And again, he had to calculate the area of our bathroom floor in order to go out and buy some new flooring that we put in. If he calculated the area wrong, I would have some empty spaces on my bathroom floor, and I would not be too happy about that. And finally, I was exploring out on my porch, and at some point coming up here, I don't know when, but I'd like to get some new carpeting for my one front porch. And in order to do that, I would need to know the area of this porch so that I can go out and get the right amount of carpet. So when we're talking about area, we're talking about the space inside of a shape. And when we calculate the area, sometimes it's as easy as counting the square units. So I'm going to go put this guy back in his tank and then come right back to teach you guys about area. So hold on one moment. All right, guys, I am back with you here. So we are on lesson 11.4 today, which is found on page 643 in your math book. And as I mentioned, today we're going to understand area. That is our main objective for today's lesson. Now, when we unlock the problem here, we need to make a connection first. And it says you learned that perimeter is the distance around a figure. It is measured in linear units, or units that are used to measure the distance between 2 points. So when we were calculating the perimeter of shapes last week, such as fencing around a garden, we were adding up all of the sides, and then that would give us our perimeter. Now, area is measured by the number of square units needed to cover a flat surface, such as covering a floor in a bathroom, covering a wall with wood pallets, covering the bottom of a tank. Anything where you are covering a flat surface, you would have to calculate the area. Now, it says a unit square is a square with a side length of 1 unit. It has an area of 1 square unit. So they show us a unit square over here to the right, and basically it measures 1 unit on all 4 sides. So we know from learning about polygons that a shape with 4 equal sides is a square. And so this is a unit square because it all has the same measurements around the outside. Okay, and they give us another image here, perimeter, showing us the distance around the shape, whereas area is the inside of the shape. Okay, so think of perimeter as a picture frame and area as the actual picture itself. Okay, if we go down to the activity, we would need our geoboard and rubber bands if we were at school, but we're just going to use the geoboard that they kind of have in our book here for us, and we'll just draw on that. It says to use your geoboard to form a figure made from 2 square units. Record the figure on this dot paper. Now, when we trace and connect the dots, we want to have 2 square units. So if I trace the shape I just made, you will see, I'm going to split it here, that I have 2 square units. So this shape has an area of 2. Now I could have also drawn a shape more vertically, and that shape has an area of 2 square units as well, because you see here's 1 square unit and then 2 square units. On letter B, it says to change the rubber band so that the figure is made from 3 unit squares. Record the figure on this dot paper. So now we just want to extend our figure to cover 3 square units, which means it should have 1, 2, 3 squares within it. I could make a shape something like this to also show 3 square units. Here would be 1, 2, and then 3. So going back to A, what is the area of the figure? Well, since both of these figures that we drew covered 2 unit squares, or 2 square units, the area would be 2. And in letter B, each of these figures I drew covers 3 square units, so my area would be 3. And you could have come up with a different way to draw a figure with 2 square units and 3 square units. So just check to make sure that the area you're covering counts up to 3 squares. Okay? Our next page here, they want us to draw 3 different figures that are each made from 4 unit squares and find the area of each figure. So they kind of just told us the answer of the area. If they want us to draw figures that are made from 4 unit squares, then the area is going to be 4 square units. But let's just explore different ways we can draw a shape with 4 square units. I'm going to make a larger square, but inside you can see that it covers a space of 4 square units. So my area is 4. Let's see, I might make a shape something like this. Connecting the dots. Hopefully your lines are a little straighter than mine. But here I have 1, 2, 3, 4 unit squares covered within the inside of my shape. So my area is 4 square units. And I might just make one very tall rectangle. And the area of this covers 1, 2, 3, 4 square units. So an area of 4. Now we have a question here to answer. How are the figures the same? How are the figures different? Well, they are the same because they all have the same area, but the shape of them looks different. The first one looks like a square, the second one looks like a backwards L, and the third one is a rectangle. So we could say same equals an area of 4 square units. Okay, and then different shapes are different. You don't have to write complete sentences here. You can just jot down your thoughts, but we need to answer both of those questions, that the figures are the same because they have an area of 4 square units, and different because the shapes are different. The shapes themselves are different. All right, moving on to the Sharon show. It says to shade each unit square in the figure shown, count the unit squares to find the area. So I'm going to use my highlighter tool to cover the squares just a little quicker than trying to highlight or to color in and shade them. You can use your pencil to shade or just make dots like I was doing before. So this space here would be 1 square unit, 2, 3, 4, 5, 6. So our shape has an area of 6 square units because it covers 6 squares. All right, moving on down here, count to find the area of the figure. Again, area is the space inside, so we need to count up all the squares. 1, 2, 3, 4, 5, and 6. 6 square units. Number 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. Makes sense. We're counting the squares, so our label is square units. On number 4, 1, 2, 3, 4, 5, 6, 7, 8. 8 square units. Awesome. On number 5, we want to write either area or perimeter for the situation. So this kind of helps us think about the difference between perimeter and area. So if we are buying a rug for a room, let's just say Isis wants a nice, pretty brown rug for her room because she loves the color brown, reminds her of chocolate. What would she need to calculate? Would she need to calculate the perimeter of her room or the area in order to buy a rug for it? Think about a rug, it's going to cover some space. So if you're thinking area, you are correct. She would need to calculate the area in order to buy a rug for her room. Now, number 6, if we're putting a fence around a garden, and I know Lucas H., he was planning a really nice garden a few weeks ago for Earth Day for his science lesson, and maybe now he needs to put a fence around it. I'm sure his crops are starting to grow, and he doesn't want any deer or bunnies coming in to munch on those crops. So if he needed to put a fence around his garden, key word is around, so he would be calculating perimeter. You got it. So perimeter is the distance around an area, and an area itself is the space within that fills it in. All right, let's keep cruising here, guys. Next page is on your own, so remember, you're always welcome to pause the video, give it a try, and come back and test your knowledge. See how well you did. That helps you know if you're understanding the skills that's being taught, or you can just continue on and work with me. So number 7, count the area of the figure. So we're counting the square units, 1, 2, 3, 4. So this has an area of 4 square units. On number 8, 1, 2, 3, 4, 5, 6, 7. Notice how I'm just doing little dots. That just helps me keep track of the squares I counted so I don't forget any or count them twice. So 7 square units for number 8. And then on number 9, 1, 2, 3, 4, 5, 6, 7 square units again. But notice how even though both of those shapes have 7 square units for their area, the shapes themselves are different. Okay, number 10. Let's count the area here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that shape covered 12 square units. Number 11 looks like a big one too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this shape has an area of 13 square units. And let's look at number 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So an area of 11 square units. All right, on 13 through 16, we need to say perimeter or area for the situation. So painting a wall. Let me tell you, I have been doing a lot of painting in my house. I was painting my bedroom, and I was going to do one wall a different color for like a little accent wall. Well, I hated it, so I had to paint over it again. And it's just been, there's been a lot of paint in my house. So let's say I'm painting a wall. Do I need to know just the perimeter, the outer part of the wall to paint? Or would I need to know the whole area of the wall to make sure I get enough paint? I'm going to need to know area for painting a wall. All right, how about number 14, covering a patio with tiles? I know Jeff has been working on, well, I should say Jeff's dad has been working on fixing up their deck and whatnot, he was telling me. And let's say Jeff is supervising his dad, covering his patio or his porch with tile or even wood. Would he need to know the area of the patio or the perimeter? Think about that. He's also going to need to know the area because he's not just going to cover the patio on the outside. And the key word here is covering. When you're covering something entirely, you're finding the area of it. All right, how about number 15? Putting a wallpaper border around a room. So let's say that Avery wants to put up a fancy border around her room. Maybe she wants it to be, sparkly stars or something like that. Now, the key word here is it's going around her room. I know wallpaper can cover the walls, but it's around a border. So Avery would need to calculate the perimeter of her room. All right, and number 16, gluing a ribbon around a picture frame. So let's say Miss Brooklyn created a lovely picture and she wants to put some ribbon around it to make a picture frame, being very creative and artsy. So if we are gluing ribbon around a picture frame, what would Brooklyn need to calculate? Keyword is around, so perimeter it is. Nicely done. Okay, number 17, go deeper. Nicole's mother puts tiles on a section of their kitchen floor. The section included 5 rows with 4 tiles in each row. Each tile cost $2. How much money did Nicole's mother spend on the tiles? Wow, so there's a lot going on in this problem. Let me get my highlighter tool and let's highlight some key things. All right, so the section of kitchen floor, Nicole's mother's putting tiles down, had 5 rows and there was 4 tiles in each row. And then it tells us the cost of each tile. And our job is to figure out how much money Nicole's mom spent. So I'm going to use my little square tool here, and I'm going to just make an illustration or a visual so that we can see what's going on here. So the section had 5 rows and there was 4 tiles in each. So, whoops, let's make this come to life so we can visualize this better. So 4 tiles in each row and there's 5 rows. So let me see if I can group this together. I think it's only going to copy 3. Yep. It's all right. Bear with me here. I'll add some more. So that would be 2 rows of 4. We need to have 5. Let's see. Is it going to work? Trying to save some time. Oh boy. Get rid of that. Technology here. Okay, so, it's way over here. That would be 3 rows. And then, here we go. This would be 4 and 5. And I just need to add 1 more tile into each row. I think pictures just help to understand the problem a little better. So 5 rows, let's see, do we have 5 rows? 1, 2, 3, 4, 5. And there's 4 tiles in each row. So we need to figure out how many total tiles Nicole's mother needs to use on her kitchen floor. So if there's 5 rows and 4 tiles in each, we can do a simple multiplication problem of 5 times 4, and that equals 20. So there are a total of 20 tiles she needs on her kitchen floor, but we're not finished yet. Remember, each tile costs $2, and we need the total. So if she's buying 20 tiles at $2 each, how much money is she spending? Well, 2 times 2 is 4, and we add the extra 0 on, and so 20 times 2 equals 40. So she would be spending $40 on 20 tiles. Okay? This was a multi-step problem. We had to break it down into a couple steps, and I think having a picture really helped me at least to visualize how many tiles Nicole's mom is using, and then I could figure out the cost of them. All right, guys, we are halfway through the lesson, so if you are feeling like you need a little bit of a break right now, feel free to pause the video, come back another time. Or if you are ready to rock and roll and get this done, then keep hanging out with me and let's cruise through this together. So number 18, our problem solving. It says Juan is building an enclosure for his small dog, Eli. Use the diagram for 18 through 19. So this is a good example. If he's building like a pen or like a cage to kind of keep his dog in when he's outside, we would need to know the area, but also possibly the perimeter. So let's look at number 18. Juan will be putting fencing around the outside of the enclosure. How much fencing does he need for the enclosure? Ooh, so the key word here was around the outside. So is he calculating the area or the perimeter? Hopefully you said perimeter because he's going around the outside. So let's count the perimeter of Eli's enclosure. I'm going to start at the top and highlight around, and you can count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I came up with a perimeter of 22. Now, we don't know if this is measuring in feet or yards, so we're just going to label it as units. Remember to put a label on your answer. Yes, Jeff, I'm talking to you. Put a label on your answer. Don't just leave the number hanging. All right, number 19, Juan will use grass sod to cover the ground in the enclosure. How much grass sod does Juan need? So now let's highlight what's important. He's using grass sod to cover the ground in the enclosure. So now we're talking about the inside of the enclosure and how much grass sod he's going to need to cover it. So are we finding perimeter or area this time? Hopefully you're thinking area because we're looking for the space inside. So let's count up the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I counted 25. And what's my label going to be, Jeff? Square units, because we were counting up all the squares inside of the shape. So we would need, or Juan would need, 25 square units of grass sod to cover Eli's enclosure. All right, let's go to number 20. Think smarter. We're going to draw 2 different figures, each with an area of 10 square units. So in order to do this, I'm going to call on Professor Berger to help us out. So take a few minutes here and watch the video, and you can draw this along with him when he gets to drawing the 2 different shapes with an area of 10 square units. Here we go.
You know, area is a really, really important idea, which actually involves taking a look at objects that we can draw on the plane, on a flat surface, and seeing how much material we would need to actually fill all that thing in. The stuff inside basically gives us area. So it's tricky business to think about, but let's see some examples where we'll make area meaningful. So first of all, what is area? Area is the measure of the number of unit squares needed to cover a flat surface. So here's what I mean. If I were to take a look at this grid, and let's say that each one of these is a 1 unit square, then if I take a look at this square right there, and I take a look at covering it, then in fact, I would require, interesting, I would require one unit worth of material, and so this would have an area of 1 square unit. There's 1 square that I outlined, and therefore the area is 1 square unit. So for example, what if I were to actually extend this picture? If I were to extend the picture and make it look like this, well, now notice that I've got that first unit square, and I've actually got a second unit square, and now a third one. So I see that I have 3 unit squares, which means the area will be 3 square units. 3 square units, 1, 2, 3. So the way we measure area is by seeing the number of unit squares that are required to cover it, fill it up. So let's take a look at a more interesting example. And let's see if I can actually get rid of these things. I think I'm doing a good job. And I'll get rid of all that. And I'll even get rid of this. And I'll even get rid of this. Now, let's have some fun. Let's see if we can draw 2 different figures, each with an area of 10 square units. So all I gotta do is draw a picture, and I have to make sure that it's covered by 10 square units. So, and there are lots of answers, by the way. There's not just one answer. There are lots of answers. I'll just draw you one. So one answer would look like this. Let's see if I can do this right now live. Here we go. So what if I draw, what if I draw this? Okay, so I start there, and then I come over. And now I'm going to go up. Now I'm going to make a kind of funny shape thing, right? So let's have some fun. Let's have some fun. We always have fun with math. So let's have some fun with this math. There. Now, suppose that that actually was going to be my shape. Well, then how many square units is that? Well, one way to do that, I'm going to draw a nice version of it right here. Isn't that pretty? Doodling, doodling. I'll put it over here. Doodling, doodling. So all I have to do is now count and see the number of squares. And if I see the number of squares, that will tell me what the area is. And so if I try it, what will I see? Well, let's see. Here's a square, so that's 1. Here's another square, so that's 2. And then I have 1 square right here, that's 3. 1 square right here, that's 4. Notice that I'm looking at the squares as just the ones that are being bounded by these 4 dots. So this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. So in fact, since there are 10 squares here.
All right, so I paused his video, Dr. Berger, Professor Berger, so that we could go ahead and draw this shape on our own. So using your Go Math book, go ahead and model the same shape that he drew, a little different like that, and double check that it has an area of 10. Okay, so it looks something like that. Now, the challenge is for us to draw another shape, another figure that also has an area of 10, but it has to look different than the first one. So I'm going to draw one and check to see that it has an area of 10. The second shape you draw could be the same as mine, or maybe you have a different idea. So go ahead and explore and see if you can come up with another shape that has an area of 10 square units. I'm going to draw this rectangle, although my sides are not very straight. 4, 5, 6, 7, 8, 9, 10. So that does have an area of about 10, not about, but an area of 10 square units. Just trying to straighten that up a little bit more. Okay. All right, so maybe you drew a rectangle like mine. Maybe your rectangle is more vertical. Maybe you drew a different shape altogether, but as long as you double count and that there are 10 square units, then you are good to go. When we move on to number 21, think smarter. We need to find the perimeter and the area of this figure and explain it. So remember, perimeter is the distance around. So let's count around. It looks like a set of stairs. So let's count around the perimeter. I'm going to start at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So measuring around the outside, I got a perimeter of 24 units. And now for the area, we need to count the space inside and see what we get. So I'm going to use my highlighter tool for this. And let's count the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I came up with an area of 21 square units. Now to explain how we solve this for perimeter, I counted up all of the side lengths and got 24 units. Okay. And then for area, I counted the number of square, go to the next line here, square units inside the shape. Wow, I can't type. And got 21 square units. Okay? So as long as we understand perimeter is adding up all of the sides and area is counting up all of the squares inside of the shape, then you, my friends, are in good shape for understanding perimeter and area. See what I did there? Try to make a little joke. I know Adam is laughing at me right now. All right. Boys and girls, we are at the home stretch, practice and homework. So let's test what we learned in this lesson. As always, number 1 is done for us. So number 2, finding the area of the shape, count the square units. And I counted 4. On number 3, 1, 2, 3, 4, 5, 5 square units, good to go. All right. If on number 4, we are carpeting a floor, let's say Drew is building in Minecraft and he wants to add some carpet down into a nice new house he's building. Is he going to need to calculate the area of his floor or the perimeter of his floor? He's going to need to calculate the area in order to cover his floor with carpet. Now, let's say we are fencing a garden, and I know Rowan was planting some crops for Earth Day as well. And let's say he needs to put some fencing up around some of the things he was planting. What type of math term would he be using? Perimeter or area? He's fencing a garden, going around his garden. He would calculate the perimeter. Awesome. All right, moving on to this diagram for number 6 and 7. Roberto is building a platform for his model railroad. What is the area of the platform? Okay, so we want to find the area of the platform, which is the space inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our area would be 12, and we need a label, square units. Number 7, Roberto will put a border around the edges of the platform. How much border will he need? So if he's going around his platform now, let's count the perimeter, the distance around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So he would need 16 units to go around the outside of his platform. Okay, we're going to skip number 8 and move on to number 1 on the back of our lesson check. Josh used rubber bands to make the shape below on his geoboard. What is the area of the shape? Count up the number of squares that you see. Area equals 3 square units. All right, awesome. And number 2, Wilma drew the shape below on dot paper. What is the area of the shape she drew? Count up the number of square units, and what is the area? I counted 5 square units. Area of 5. All right, number 3, Leonardo knows it is 42 days until summer break. Is anyone counting how many days until our summer break? Lucas? Anybody? Ricari probably would know how many days are left. Well, as of today, and I have to think of when I'm making this video. So I think that there are just like 14 days left. That might be right. Okay, anyways, they give us a hint that there are 7 days in a week. So how many weeks is it until Leonardo's summer break? So if there are 42 days, and if we divide that by 7, because there are 7 days in a week, that'll tell us how many weeks add up to equal 42 days. So this is where your math facts practice comes in handy. Who's been practicing their facts? Liam, have you been practicing your division and multiplication? I hope so. So we get 7 weeks as our answer. 6 weeks as our answer. See, this is where you guys I'd be checking to see if you guys are paying attention. You'd be yelling at me, Mrs. Jockel, it's 6, not 7. All right, just have to make sure you guys aren't sleeping on me. All right, number 4, Nan cut a submarine sandwich into 4 equal parts and ate 1 part. What fraction represents the part of the sandwich that she ate? So a submarine sandwich. Wow, look at that. All right, and if she cut it into 4 equal parts, I know my parts aren't going to be equal, but you get the idea. And she ate 1 part. We'll give her this end. I usually don't like the end parts of a hoagie or sandwich because they have too much bread. I like all the good stuff inside. All right, anyway, so if she ate 1 part out of the 4, her fraction that she ate is 1/4. And you can write that as a fraction or you can spell it out, 1/4. Remember, our numerator is the part that we are talking about, the shaded part, 1. And the denominator is how many total parts there were, 1/4. All right. Number 5, Wanda is eating breakfast at 15 minutes before 8. What time is this? So, what time would Wanda be eating breakfast if it is 15 minutes before 8? So if it's before 8, we have to go 1 hour before, and what comes before 8 is 7. We put our colon to separate our hours and minutes. And remember, if we are at the 12, our minute hand is pointed at the 12, that would be 8 o'clock, but now we need to go counterclockwise 15 minutes. So 5, 10, 15, we would now be pointing at the 9 on our clock. And so what does the 9 represent in terms of minutes? I know Brielle maybe could answer this one for us. She's very good with time. And she's usually checking in with me at about this time each morning. The 9 represents 45. So it would be about 7:45. Now, is it a.m. or p.m.? If she's eating breakfast, we would say a.m. Very good. All right, and number 6, Dick has 2 bags of dog food. Each bag contains 5 kilograms of food. How many kilograms of food does Dick have in all? Well, he has 2 bags of dog food, and each one is 5 kilograms, 5 kgs. How much does he have all together? Think about this one. What are we going to do? 2 times 5 equals 10. And what's our label going to be? What's our label? 10 kilograms, because we're talking about the weight of the dog food. All right, boys and girls, it was so much fun hanging out with you today, although I'm just hanging out with my computer. I miss you guys all very, very much. I love all of the hard work that you were doing. Every assignment that you turn in, I can tell you've worked really hard, and I just know that you guys are doing the best that you can at home, so keep up the good work. Please reach out to me if you have any questions or need any assistance. There are some extra resources on our Google Classroom page for math under Chapter 11, some enrichment pages to challenge you a little bit, and some reteaching pages if you need a little extra help. But I wish you the best with the rest of your work for this week, and have a great day. I'll see you guys soon. Bye.